Good evening, everyone. Today's session is on evaluation, the last phase of AI project cycle. And in this phase, we will be talking about like what are the different elements, what are the different terminologies we are going to use for evaluating the model, right? So basically, like in the previous steps, we have seen you have the complete cycle, and we are talking about the five phases of AI project cycle, right? So the first phase would be your like when you identify the problem. So problem scooping. The second part would be your data acquisition when you acquire the data that is related to your problem statement. And then you basically clean that data, you explore that data uh, according to your like it is relevant to the problem or not, right? You clean that part, like whether your images, the collected data, if it is repetitive or there are some outliers. So then you have to work upon that. Then after that, you use the modeling techniques for basically training the system, right? And the end phase, the last phase, the final stage of AI project cycle is evaluation. So today I have started with this, and let us understand what do you mean by evaluation? What are the different cases we have in our evaluation phase, how it is recorded in confusion metrics, right? So we will be focusing on the four conditions, right? Your true positive, true negative, false positive, and false negative, and how you calculate that part, right? And how you record all the results in the confusion matrix. So first of all, the first phase is evaluation. Now, what do you mean by evaluation? It is the basically the final stage of AI project cycle where you are going to check the reliability, check the performance of the model. Right. It is the phase where you are going to check out all the things. What is basically your model is a giving a good performance or it is giving a poor performance according to the F1 score. So there are different evaluation metrics which is going to be used, right? For like if it is you are checking the accuracy of your model, you are checking the precision of your model, you are checking the recall factor of your model. So all these metrics are used to evaluate your system, right? So it is just like that. You test the system, you check out whether it is going to serve the like right outputs or not, accurate results or not, right? One important point here we have is overfitting. What do you mean by overfitting is it is not recommended at all to use the data, the same training data set for testing the model, because obviously it is going to provide you the accurate results. If I have supposed I have trained the model with such figure, such image, right, like my hand, I am training a face recognition machine with my hand, this image, and later on I would be checking this image whether it is showing the correct image or not. So obviously it is going to show the correct image. What about the testing images? Like I should show like this, that, or some other pattern of my hand, right? So it is basically not recommended to use the training data set for testing the data. Otherwise it is basically it leads to a situation that is called overfitting, right? So let us start with the evaluation process. The first case that I have taken and how we have evaluated it, let us see this point, right? So the question was, case 1 question was, is there a forest fire? Is there a forest fire? You have two variables here, prediction and in reality. Now you are going to check out. Prediction is yes, there was a your model is trained with that and it is predicting yes, there would be a forest fire. And in reality it happens. It matches with your prediction. It matches with your outcome. So when your prediction matches with the reality, that means you get the what you get the result that is true. you get the result that is true. When your prediction matches with the reality, you will get the result that is true, right? And if the prediction, whatever the value of prediction, like yes means positive, no means negative, right? Yes means positive, no means negative. So basically your this output is divided into two parts. This true value depends on whether your values, prediction and reality are matching or not. And this positive basically is taken from the value of the prediction, right? So this is how it is calculated, because most of the student get confused. True positive means, so true positive basically means the model predicts yes, which means there is a forest fire. The prediction matches with the reality, hence the condition becomes true positive. So where this part is segregated, where it is written, so whenever we calculate it, no need to learn anything. The basic understanding is, if prediction matches with the reality, that means your result comes true. Yes, it matches with the reality. Next part is positive. How to use this part positive, how to calculate this part, whatever the value of prediction, you have that. You have to take that value. Yes means positive, no means negative. So here the result, both the values are matching, you have the true positive case, right? Taking as a another case, right? So here we have the case 2. Again, the same question. Is there a forest fire? Right? The prediction was no. And in reality, yes, it was not happened. There was no forest fire. Right? So, your result matches? Yes, you will get true. Okay? Now, how you are getting negative? Whatever the value of predictive value, prediction value. So, here your prediction value is no, that means negative. Yes, both the things are matching. Reality matches with the prediction part. That means both the things are matching. Yes, right? It matches with the prediction. Now let us take the third example. Case number 3. Is there a forest fire? The prediction was yes, there is a forest fire. And in reality, there was no forest fire. So here, one yes, one no. Your result will become false. Prediction was that was predicted. Yes, there was a forest fire. But in reality, it won't happen. Right? So basically, in this case, reality is no, prediction is yes. You are not matching. Both the conditions are not matching here. So what we need to do is, we have to take, when both the results are not matching, that means false. Whatever the value of prediction, yes, that means positive. This is how we take the next condition, false, positive. Next, is there a forest fire? Prediction was no. There is no forest fire. But in reality, yes, there was a forest fire. What happens? Result matches? No, the result does not match with each other. So we have false condition. Whatever the value of prediction, no means negative. So we get the condition false, negative. So this is how we calculate all the 4 conditions. True positive, true negative, false positive, false negative. So we have discussed all the 4 conditions, right? Now let us start with this. Let us start with the confusion matrix. Again, I am repeating, in my earlier session also have discussed this thing. Confusion matrix is not an evaluation metric. It is just a recording of results. What are the values of true positive, what are the values of true negative, what are the values of false positive, what are the values of false negative. It is just like that. It is recording of the results, what we get from the system, what we get from the model. It is just recording of that, nothing else, right? The result of a comparison between prediction and reality can be recorded in what we call the confusion matrix. The confusion matrix allows us to understand the prediction results. Note, it is not an evaluation matrix. Again, I am repeating, it is not an evaluation metric but a record which can help in evaluation. You are going to take all these values for calculating the accuracy, for calculating the recall, for calculating the precision, for calculating later on F1 score. So basically they all are they all are having the same thing, right? They all are having the four conditions. So whenever we are talking about confusion matrix, it is going to work like this, right? But the main thing that we have to understand is how to use this, how to use this confusion matrix. Let us understand that part also. You have first condition, case 1, that is true positive. So I told you how to have a true positive condition when both the results are matching, when both prediction and reality matches. We have the true part, I told you. And when whatever the value of prediction if it is true, that means you will get positive. So this is how you are getting the true positive part, right? Case 2, true negative. When prediction and reality both matches, they have the result actually matches with the reality, right? But the value of prediction is false, then you get negative part, right? That is true negative. False positive, prediction do not matches with the reality. That means the results are not matching. When they do not match with each other, you have false condition. And but the prediction value is true, that means it is false positive, right? Then we have false negative. Prediction and reality do not match with each other, right? So it is going to give you false. And when prediction is false, you get negative out of it. So this is how we record the confusion matrix, right? How to record confusion matrix? The first, here you write down the reality and here you write down the prediction. And most of the time, like what we do is we write like this: yes is for 1 and 0 is for no, right? So if one condition, if yes, reality is yes and prediction is also yes, so you get the condition that is true positive. Again, both are no, both are matching, no and predicted value was also no, both are matching, true negative. You will get this. This is how we record. You may basically you may do one thing, like in some books it is showing uh, reality on this side and prediction of our side. You can write it in any of the method. The main thing is the calculation, the conditions calculation part, where you are putting 0 and where we are putting this 0, and then you write down the result, right? Now here prediction was 1, right? Means yes, but in reality it is not matching with the result, so you get false, right? Because the prediction value is yes, so that means it would be a false positive. Again, in this case your result does not match with each other, it is true and this is false, right? And but the value of negative is prediction is false, so you will be getting negative. So prediction and reality can be easily mapped together with the help of this confusion matrix. So basically confusion matrix we are not having any evaluation kind of thing. It is just a recording of results. How many cases comes under this? How many cases comes under this? How many cases comes under false negative? How many cases comes under true negative? So this is how we have the confusion matrix in our program. The only thing that we use in confusion matrix is calculation of results, recording of results, not computation, no computation, just recording. How many values are true negative? You are going to write down here. How many cases are false positive? You have to record that part. Now let us have a look on evaluation methods. How to use these four cases. How to use true positive, false positive and true negative in your evaluation method using accuracy. So I have explained two of them with some examples also, right? So let us see that part, how to use these four conditions in accuracy. So you have accurate. What is accuracy? Basically accuracy is defined as the percentage of correct predictions, all the correct predictions. It only talks about what the correct predictions made by the system, right? So correct predictions out of all observations. So you are taking all the four conditions on the as a denominator, right? So here we have our prediction can said to be correct if it matches with the reality. Yes, so that's what we have seen. If it is matches with the reality, that means you get the true positives. Or if it is matching, both the results are matching, you are getting true negative, right? Here we have two conditions in which prediction matches with the reality. Yes, we have seen this part. Here both the results are matching. Prediction was yes, reality was yes. You got true positive. Here prediction was no and in reality it was no. The result was matching. That was true negative. So they both are the correct predictions, right? So here what we have taken, true positive plus true negative, right? Divided by total number of observation, all the four cases, true positive, false negative and true negative, right? And into 100, then you calculate the percentage out of it, like how much accurate is your model is, right? Let us take an example. Prediction always no, in reality 2% probability of yes. Accuracy is 98%, right? But is it usable? Let us see. This is fairly high accuracy for an AI model. Basically, whenever we go for accuracy part, it is 98% is such a like it is a excellent model, we may say, right? But this parameter is useful for us as the actual cases where the fire broke out are not taken into account. Hence, there is a need to look at another parameter which takes account of all such cases as well. So that's why there is another thing that we have, that is precision. Precision is defined as the percentage of true positive cases versus where the prediction is true, right? So here what we talk about only positives, nothing else, whether it is false positive or it is true positive. So precision basically talks about all the positive part, maybe true positive or false positive. So here when we talk about the true positive and false positive, how to calculate that part, let us see in a formula. Precision is equal to true positive. You take all the true positives on the numerator and all predictions that are positive. We are not considering any negative thing, right? Any negative means when the results are not matching, we are not taking it. So this is the drawback. I will be taking this part. So basically we are not talking about the false negative or true negative part. Only positives we are taking in precision, and then we calculate the percentage. Going back to the forest fire example, in this case, assume that the model always predict that there is a forest fire irrespective of the reality. In the case, all the positive conditions would be taken into account. True positive means realities matches with the prediction. False positive, yes, prediction matches with prediction is equal to yes and reality is equal to no. In this case, firefighters will check for all the fires all the time to see if the alarm was true or false. Right. So again, it has put one condition. It is lacking one part. So then we have, let us see one explanation of this. So suppose we have prediction 10 cases of true positive and 20 cases of yes. 100% precise. Is it usable? Let us consider a model has 100% precision. Which means that whenever the machine says there is fire, there is actually a fire, true positive. In the same model, there can be rare exceptional case where fire was actual, but the system could not detect it. This is the case of a false negative condition, but the precision value would not be affected by it because it does not take FN. I told you, no, it talks about only positive part. Where is the negative? Whether it is false positive, whether it is true positive, it is only concentrating on positive part. So because it does not take FN into account, is precision then a good parameter for model performance? No, obviously. So we have recall in that case. We have a recall in that case, right? Recall basically takes the false negative part out, where that is, it takes into an account the false negative. You have true positives. In that case, you have true positives plus false negative here. Rather than taking the all the positives, it takes false negative also. So this is the basic difference also. When we talk about the positives one, because here also we are talking about only the correct predictions. What about when the predictions are incorrect, when the prediction are not matching with the result, then what we have to do? So basically to look upon that, this come into the picture, that is true positives. We are talking about false positives now. Here we are only talking about the positive ones, right? Now what about when we have false negative part? So that comes in the another evaluation method, that is recall, right? So here I have used, the main concept was this confusion matrix. How to make this confusion matrix, how to basically derive true positives, true negatives, false positive and false negative, right? Basically these are converted into errors only later on. So where we are getting the error? When we have this thing, when the result is matching with the prediction, there is no error in the program. But when we have the false part, then the story of errors would be coming into the picture. When your prediction is not matching with reality, in both the cases our prediction is not matching with the reality. Now what would happen? Yes, it leads to an error, and that error needs to be checked, right? So from basically like false positive and false negative part, we are going to understand the error part. So we have like assumptions how to have type 1 error, type 0 error. So In other lectures, I will be in other sessions, I will be telling you about the numericals, how to have a case scenario, how to take the false positive false, how to calculate these four cases basically, and then I will apply the evaluation metrics so that you have an idea how to calculate it, because most of the time people get confused how to make this confusion matrix. Sometimes they, what they did is they write something else, they change the value, and of course reality is changed with actual values also. So like when we do programming, when we basically makes confusion matrix, we might be using some matrix, or we might be using cross steps also for confusion, for the representation of confusion matrix. So basically crop steps is also a method that is a tabular representation of database only, your data set. So we may be using cross tabs for representing the confusion matrix, so that the goal is to basically understand how to make this confusion matrix, and hope you have understood how these four cases have been derived. So hope you like the session. Thank you.